Welcome back. In this video, we are going to be setting up our local environment using Docker and Docker Compose. If you don't have Docker Compose installed, go to the documentation and follow the instructions to install it. It's usually just a binary that you download, and that binary you will use to interact with the Docker engine. For this example application, we are going to need 4 services, and I say service because that word is actually important. That's how we describe our application in Docker in terms of Docker Compose. You can think of a service as kind of a load balancer for your containers. So yeah, we are going to see that more in depth when we are actually using it. But for this application, we are going to need a PHP FPM container, which is our application container, then an Nginx container. This is the official PHP image. There are different flavors here that we could use, like there is an Apache 2 flavor, but we are going to be using FPM because that's the one that I use most. And we are going to also need an Nginx service as our web server that talks to the FPM over TCP sockets. And we are also going to need a MySQL service for, our database, and a Redis service for our sessions and caching and queues that we might need. If we were going to run all of these services manually using Docker CLI, just the Docker CLI, we would have to spin up a PHP container using the FPM flavor and then the MySQL container, linking that to the FPM container. Yeah, we don't want that. We want a declarative way of running all those commands in one go, and that's why we need Docker Compose. So let's get started. We are going to create a Docker Compose file here, dockercompose.yaml, and we are going to use the version 3, and we are going to describe our services. We are going to have a PHP service, and that service is not actually going to use the image. We are going to have to create our own image based on PHP's image. And what we can do here, we can describe how Docker Compose should build that image. And I'm going to just specify the context. So when you're build from this context, which is the base folder. I need to create a Docker file here. So Docker Compose, when it's building the PHP service image, it will look for a Docker file in this context. I could specify the Docker file that I want to as well, like if the name of the Docker file wasn't the default name. But yeah, I'm using the default name. And now we are actually going to describe our image. So how we want to tell Docker how to build this image? We want it to base from PHP's 7.4 FPM flavor. And we are going to change the working directory to be var www.html. And now we are actually going to install some dependencies because we want this image to be used locally, and that's why we are installing Composer in the image itself. And Composer has a dependency on the libzip and the zip extension on PHP, so we are going to be installing that. So first we are going to run apt-get update and apt-get install -- quiet, because we don't want anything verbose. We want yes for everything. So apt-get will not ask us on anything. It will just rely on the yes that we installed. We don't want to install the recommended dependencies, just the ones that we are actually explicitly listing. And now I'm going to use the \, and we are actually going to break a line here, and I'm going to specify which dependencies that we are going to install. So we are going to install libzip.dev and unzip. These are the 2 extensions that we need. And after that, we are actually going to run docker php extension install, and we are going to specify the zip. This is all we need to install Composer. I'm going to actually change this formatting here because it's a bit weird. So this is actually what we need for Composer, but the PHP image doesn't come with any database drivers installed, so we have to install it. And to do that, we are going to specify here that we need the PDO and PDO MySQL installed as well. As we are going to use Redis for our image, we also need the Redis extension. And unfortunately, we can't install it like that. We have to install it via pickle. So we can do pickle install -o-f and specify the version that we want, which is Redis 5.1.1. And after that, we have to enable the Redis dependency. And we can do that using another helper from the PHP image called docker php xt enable and specify Redis. The xt install will automatically enable this, but this one was installed via Pickle, so we actually need to run this. And now we can actually install Composer. So the way we are doing that is using something Docker calls a multi-stage image, but we are not going to be talking about multi-staging here. Besides, using that to install Composer itself, I'm going to be covering multi-stage images in the production tweaks, in the production optimization videos. So for now, it's enough to know that we can copy a file from the Composer image, and that file will be the Composer binary under user bin Composer, and we are going to copy that to user bin Composer. So we are copying this file to this location in our image. This essentially installs Composer in our container or in our image. And now, remember that we specified a user for our container when we were creating the Laravel application. We have to do that here again. So I'm actually going to copy this piece because I got it from blog post that I'm going to link in the references. But the idea is that we are going to create an app user, and that user has an ID of 1000. That maps with my local user ID, which is also 1000. So this will make sure that any file created inside the container, and we are changing the user here. So any files created inside the container will be from the correct permissions. So now, let's go back to the Docker Compose description, and we are going to do one more thing here. We are going to share a volume. So remember when we were using Docker run and we specified the -v flag and we specified the local folder as the folder that we wanted? Well, we can do that with Docker Compose as well. So we just have to describe here which folder we want, which is the dot, and we want to map that to var www html. And I believe that this is it. So let's run it. Oh, there is an error here. Oh, I'm sure you noticed that, but it should be installs here. And let's try that one more time. So it just finished, and now if we run docker compose ps to list all our service, we can see that the PHP container is running. We can interact with it in the terms that we can actually execute a shell, like execute the command inside the container. So we are going to execute inside the PHP service this command bash. And for that we can actually see that our volume is working because it shared a folder here, and it's good. As you might have noticed, there is no mention to a PHP or to a web service. That's why we are going to install in Nginx. So we are going to specify here a web service, and that web service, we are not actually going to build it as we did for the PHP. We are going to need to do that for production, but for local we don't need it. What we are going to do is we are going to specify the image, which is Nginx 1.17, and we are going to change the working directory here to be var www html, and we are also sharing the volume with our container, which will be var www html. We need to share our site configuration with the Nginx, so we are going to create, this doesn't exist yet, we are going to create it still. So we are going to create a .docker folder, and in there we are going to have an Nginx folder, and there we are going to have an Nginx template local.conf, and we are going to share that with etc nginx confd default.conf. Let me see if there is a typo here. Default.conf, no, that's okay. There's one thing that we need to do that we didn't do in the PHP, because we don't interact with PHP FPM directly. It does that via Nginx. Nginx is the one that talks to FPM, so it's able to talk to it via Docker networks internals, and we don't have to expose the PHP process. However, we do have to expose the Nginx process, and we are going to do that now, sharing a port. So we are going to be sharing the port 80. This means that I want to bind my local port 80 with the containers, the Nginx container port 80. And before we are able to run it, we actually have to create the site template, and we are going to create that folder structure here. So we are going to have a .docker and Nginx, and inside there we are going to create an Nginx template local.conf. And if you don't know how to configure your site, you can go back to Laravel documentation and search for Nginx, and there is a suggested configuration that we are going to use here. So we are just going to copy it and paste it in our template, and we are going to make some tweaks. So for the server name, we actually don't care, so we're going to specify underscore. For the root folder, we have to share our public folder, so we are going to do that. As I mentioned, we are going to map our current folder with this folder. So yeah, our public folder will be here. All looking good here, nothing to change. And yeah, so this part is where Nginx talks to FVM, and it's assuming FVM is running in the same server, so they can talk over Unix sockets. But since they are using on different containers, the way they can communicate is using TCP sockets. So the way we can do that is changing this to either the IP and port that we want, that our FVM process is running, or we can use a host name. And for this case, we are going to use PHP as the host name because that's how Docker Composer works. So as I said in the beginning, Docker Compose services is almost like a load balancer. So there's a service in front of your containers, and that service name can be used as the host name to interact with your containers, PHP containers. So that's what we are doing here. And one more thing, we have to redirect our logs and error files to standard out. Yeah, this is so we can actually see the logs if we want to. And with that, I think we are done. So let's try now. So let's run docker compose up-d. And if everything went okay, we can actually run docker compose ps and see if everything is fine, and it looks like it is. So we can actually go back to our browser and run an open localhost, and we should see our application, which is awesome. Now let's go back to our Docker Compose, and we are going to specify yet another service, which is our database. So for that, we are going to create a DB service, and we are going to use the MySQL 8 image. And we are going to specify some configurations here. So MySQL, we can configure the MySQL container using environment variables. If you go to the documentation here on the image, you can see that we can use environment variables to configure most things. And we are actually going to specify them here. So we are going to specify the MySQL empty password to yes, so it allows us connecting with empty passwords. And we also going to change permission to allow connections from any host. And besides that, we also have to set the root password. And we could specify here our password, but Docker Compose also reads our .env file, which is everything in Laravel we configure via environment variables, and locally we have the .env file. So we are actually able to use these environment variables as well in our Docker Compose file. And what we are going to do here is actually, as the root password, we are going to use the DB password. Right now it's empty, but it could have some values there. And we're also going to specify the database name, the default database name, as DB database. And our user to be DB username. And now, yeah, our user password is also going to be needed here. And we can use the same string here, the same password as the root. So this is what we need to configure in this container. However, there's one thing. Containers are ephemeral by nature. So any data that we created inside this database, it would be lost once we stop the container and restart it. Let's say in the following day, like we are working on a feature, we stop working, we stop the containers, go back the next day and boot it up again. That data would be lost, and we don't want that. What we have to do here is to use volumes. We have used volumes here to share our local files with the container, but this one, we actually don't care where Docker persists this data, as long as it's persisted. So what we are going to do is we are going to specify a named volume. So we are going to create a named volume called MySQL data, and we are going to share that with var lib MySQL. That's where MySQL will store data in the container. So we have to create this named volume here, and we are going to do that by specifying volumes here, and MySQL data is the name of the volume. We don't have to configure anything because we are going to use the defaults for this one. So with that, I think we are able to put MySQL now. If we run docker compose ps, we can see that MySQL has booted and looks like everything is fine. So let's try to run the migration. So to run the migration, any command that you need to interact with Artisan or anything in your PHP workflow, you can do that via docker compose exec php. And this time we are going to run the migration. So Artisan migrate, and let's see. Yeah, so we got a connection refused. If we see the .env file, we can see that it's the DB host is trying to connect to localhost, which isn't where MySQL is running. So as we did for the PHP, for Nginx to talk to PHP over the service name as the host, we are going to do that for database as well. And the host name for the database is just DB. So we are going to change this to just DB. And we don't have to restart anything because Laravel will pick it up. So if we run it again, we should see the migrations running successfully. So now let's generate the auth scaffolding for our Laravel application so we can see some forms and interact with our database. For that, we are going to run docker compose exec php, and there we are going to actually get a terminal this time. From here, we can actually run composer require Laravel UI, and that should take some time. Actually, let's do differently, because remember that we used caches before. So I think we are actually able to use caches here as well. So let's see. I'm gonna run rm and I'm gonna share the home cache composer with /tmp, and I'm going to specify the composer home as /tmp. So I'm going to run, instead of bash, I'm going to run composer require Laravel UI. Let's see if that works. So that's installed, and now we can actually run docker compose exec. You see that now I'm using exec instead of run. I used to run here because I wanted a new container, and that's why I used the --rm. So once composer finished running this command, Docker could delete the container. And this time I'm using exec because I actually want to run this command inside an existing container. I'm going to run it in the PHP container, and I'm going to run the auth scaffolding command. Now we can go back to the browser and refresh, and we should see the login and registration form here. And we don't see any styles here because we don't have them compiled. So let's go back to our application and tackle one service that I haven't thought about until now. So Laravel comes with some front-end settings for us. It has some JavaScript that we can use, as well as some CSS. Well, it used to come with Bootstrap, but not anymore. We are going to actually be using Bootstrap here, so that's why I'm going to use docker compose exec php, and I'm going to use the UI scaffolding to actually swap my front-end assets to use Bootstrap. So this should create the files that we need. So yeah, see, it's relying on Bootstrap and stuff, and actually I don't have Bootstrap installed or anything, so we are going to actually have to run it. We are going to specify another service here called, I'm going to specify before the database one. It's going to be called node, and it's going to be based on node 12 image, and we are actually going to specify the user for this time, because the node image already has a user called node that we can use, which shares the same group and user ID as my local ID, so I can actually use that. And we are going to map some volumes here as well. So we are going to map my current volume as /assets inside this. And we are going to set the working directory for assets. We are going to specify this time a command that we want to use in this service. So if nothing is specified, then Docker Compose will use this command for us, which is npm run watch. So we will always have the watcher running. If we boot up this service, it's going to fail because it's relying on the npm dependencies installed, and we don't have that yet. So we are actually going to, before we start it, we are going to run it --rm, and we are going to run the node service, and we are going to run a command inside of it, which is npm install. So it's done running, and now we can actually run docker compose up-d, and that should boot the node service, and our watcher should be running now. So yeah, it's running npm and states it's up, so should be working. And if we refresh the browser, we should see some styles. Or is it still running? Yeah, it's still compiling, because the first time it will take some time, so let's watch on that. Of course I used the wrong order. So it's compiled successfully, and if we go back now and refresh, we should see the styles already working. This means that if we actually change here anything, let's put an alert here, hello Laravel, and save. Once we hit save, our watcher is running, so if we refresh, we see the already compiled assets. So that's good. With that, we have another service here, which is our watcher. There is still one missing, which is Redis. And Redis is actually much simpler to install, let's put it like that. So we are going to create another service here called Redis, and we are going to use the Redis 5 image. And the same thing that we did here for MySQL, we are going to use here, but instead of this volume, we are going to create another named volume called Redis. And Redis stores its data in a /data folder. So that's it. That's how we actually install Redis. So if we go back here and use up, and we should see Redis running, and we should be able to interact with it like Redis, and we are going to run this Redis CLI command inside the Redis service. So yeah, it's working already. If we go back to our PHP application and run PHP artisan tinker, we should be able to talk to Redis like this. Well, let's use this set command for our counter. And yeah, it won't work because I think it's not using the facade. So let's use it. Support facades and Redis, and let's try the ping command again. So connection refused. We have seen that before with the MySQL image. So let's go back to our .env file and change the host name here to also be the service name, which is just Redis. And let's try Tinker again. Let's run the ping one more time, and we got a true. Not what I was expecting, but yeah, if we set the counter to 1, yeah, we see 2. If you get the counter now, it should be 1. Yeah, okay. So if we increment the counter, yeah, it's working. Yeah, that's it. That's how you use Docker to create your local setup environment. And let's change the README here to describe the commands that we need to set up when we start working on this project. So this is the setup instructions. There are some requirements, Docker and Docker Compose, and before running Docker Compose up-d for the first time, you actually need to run the composer install and npm install, and then you can actually run Docker Compose up. So that's it. That's how you create your local environment using Docker in Docker Compose, and I hope you liked it, and see you on the next video where we are going to talk about production optimizations for this Docker file that we created.